Hello, class. So let me first apologize by forgetting to tell my Tuesday night class that this week's copper lab, has a unit conversion and dimensional analysis worksheet that is due with it. Now, originally I was just going to push it back a week, but I decided not to. Now that this disadvantages my Tuesday night class, and for my Tuesday night class, I'll let you turn them into my box by Thursday. I'll give you 2 extra days. But for everyone else, my Thursday and Monday night class, it'll be due when you turn in Copper Lab, uh, your Copper Lab report. Now, if you have it done on Tuesday for my Tuesday night classes, please go ahead and turn it in. I'm shooting this video because I didn't have time to go over it in lab. Um, I wanted to make sure we had time for the actual Copper Lab, and I wanted to kind of stitch a few labs together. So I apologize for that. But I'm going to show you how I set up dimensional analysis problems, how I utilize my conversion factors, and how I do unit conversions. And hopefully, by watching my video, you'll be able to establish a systematic approach to doing this that will allow you to consistently and quickly complete dimensional analysis and unit conversion problems. It'll save you time on the test. It'll reduce your anxiety once you know how to do it more quickly. But I'm also hoping that you'll see how to present your work in a way that allows you to get the maximum number of points should you get the problem wrong. So it's not just a matter of knowing how to do it. It's a matter of showing your instructor that you know how to do it, and the best way you can do it is to show it clearly. Now, when someone says show your work on a dimensional analysis worksheet, there is no there is no like D equals M over, excuse me. Let's try a different pen here. You're not going to be showing like a D equals M over V, or maybe V equals length times width times height. So there's no equation, but there is a method. So let's just jump in. I'm going to show you a couple, and I believe if you have any questions, you're welcome to ask me. I'll have office hours today. I'll have office hours on Monday. I'll have office hours on Thursday. So I'll be around if you need me. Just let me know if you're coming to my office hours, because I may be out and about doing something else. I want to make sure that I'm present for you. So we're going to do this first question. It's really simple. How many meters are 34.2 inches? So the way that I do this, I go, okay, let me set up my roadmap. I know that I'm starting with inches, and I know that I'm going to meters. Okay. So I have this conversion factor that says 1 meter is 39.37 inches. Now this is an exact number. It's 1.000, as many zeros as you want. This has 4 significant figures, and I promise you that this decimal continues afterwards. Here we have 3 significant figures. So we're going to come back to that in a second. So I see, first of all, the first thing I do is I set up my roadmap. We're going from inches to meters. We're going from Cumming to Atlanta. We're going from Kennesaw to Tuscaloosa, whatever. I want to make sure that my units are set up first. So the first thing I work with are units long before I put in numbers. So I need my inches to cancel out, so I'm going to put that on the bottom, and I need meters to be left behind, so I'm going to put that on top. Now I'm going to turn this into my conversion factor, and I'm going to start plugging in numbers. So 1 meter is 39.3 0.37 inches. There we go. All right, so now I can walk my line. I know that my inches are going to cancel out. I know my meters are left behind. I have a conversion factor. I have my units. I have my units in my conversion factor. I have my numbers. I've looked at my significant figures here. I've looked at my significant figures here. And I know in the end, I'm going to end with 3 significant figures. So I'm going to put 34.2 inches. And when I calculate that out, now what I typically do is I'll put a couple of extra significant figures. So my handy iPhone calculator tells me that 34.2 divided by 39.37 is 0.868681. 0.8686. Now clearly that's more significant figures than I want, but I always, if I want to have 3 significant figures, I always come one extra so that I can show that I'm rounding up. So the real answer would be, with 3 significant figures, that would be 0.8, excuse me, 869 meters. Now, to me, this is a great way to show your work. You've kept your units the whole way. You've shown what cancels out. Your numbers are here. It's clean. I can tell that you're showing that you know how many significant figures are here. You're showing that you rounded to the correct significant figures. Like, this is perfect to me. And this is exactly how I did it in college and when I did it in graduate school. And I never got points taken off unless I did a math error, because every aspect of this conversion, of this dimensional this unit conversion is clear. So if we were to go down to here, how many inches are in 45.3 kilometers? So I got inches to kilometers. Now I'm going to look up here and see, okay, I've got inches, sorry. If I want to go from inches to kilometers, I have miles to kilometers, so I could go from inches to miles, but there's no conversion factor up here for that. You only use these conversion factors. There is an inch to meter. So for this one, I'd be looking at going from inches to kilometers, excuse me. Let me do it this way. This is kind of going to be like a 2-step problem. So I'm going to go from inches to meters, because that's what we have up here. And then I can go from meters to kilometers. All right. So now this is my roadmap. And I'm not going to turn this into my actual equation. I'm going to keep this roadmap out. I'm going to go, okay, let me see. I need to have 2 conversions. One that gets me from inches to meters. One that gets me from meters to kilometers. And at the end, I should have, oh, I did that backwards. Let me do that again. I'm so sorry. All right. Play with your phone for a second. Let me get this stuff erased. All right. So we're starting off with kilometers. Well, I see that I can do meters to inches, and I have meters here, but I just have kilometers. So we're going to go from kilometers to meters, and then from meters to inches. All right. So we're going to start with kilometers, and we're going to end with inches. All right. So let's put in some conversion factors. I know that 1 kilometer equals 1,000 meters, and I know that 1 meter is 39.37 inches, all right? Well, I need my kilometers to cancel out with meters, and that takes care of this conversion. Now I need my meters to cancel out with inches, and that handles this conversion. Now I can just look at my numbers and say, okay, 1 kilometer is 1,000 inches or meters, and 1 meter is 39.3, excuse me, 37 inches. And I can't get my little script in here. 39.37 inches, all right? I see that I have 3 significant figures again, and I still have 4 there. So I would plug in my 45.3, and then and I'm not going to do this one for you, but I would do this similar as I did here. So I would do 4 significant figures, well, for crying out loud, it's not even worth it. 4 significant figures here, and then I would round it to 3 significant figures here. Does that make, I hope that makes sense. So again, I set up a roadmap, kilometers to meters, meters to inches, identifying that I have a meters to inches conversion and a kilometers to meters conversion. And then I went kilometers, and I created space for my 2 conversions. I filled in my units first so that I can walk the line and make sure that my kilometers cancel out with kilometers and my meters cancel out with meters, and that my inches is what's left behind. Then I plugged in my units. I said, all right, 1 meter, right? 1 meter is 39.37 inches. And then I just clear it. All right, got that one. And then I used, this is something you just have to memorize, that in 1 kilometer there are 1,000 meters. I plug that one in. Finally, I check my significant figures, write my number. I go to an extra significant figure here, and then I round down. To me, that is just spot on perfect. No one can question your work. No one, like, you'll get 100% credit. Even if you do your math wrong, you might lose a point for your math, but they'll see that you know how to do everything else. You just have, like, you know, meat sausage fingers and you're hitting the wrong button or something. I always do recommend doing the calculation more than once. These are all pretty easy. You know, here, for instance, now when you're doing, so a little trick here. So it says an index card measures 4.0 inches by 6.0 inches. Find the area of the index card and report your answer in meters. Now, because you're finding the area, you do need to have an equation. Area equals length times width. You do need to have that equation. Up here, because you're doing density, you do need to show an equation. So when it's saying, oh, sorry, that's a lie. Ignore that one. So on this one, because you're given the density in grams per centimeters cubed and you're doing a pounds to gallons conversion, there's no equation here. There's no density equation. But because you're doing the volume, or you're finding the area, and they give you the length and the width, you have to show your equation. So if the equation is not given, show it. But here, you're just converting. So this solve for density, you're really not solving for density. You're really converting density. Now, oftentimes people will do like inches times inches, and they'll get inches squared or square inches, and then they'll try and convert square inches to square meters, and they'll do whatever the meter to inch conversion is up there. But this is wrong. there's 2 inches up here, but there's only 1 here. So even if I cancel out 1, I still have 1 left over. There's only 1 meter here and there's 2 here. So this is not correct. If you want to go from inches squared to meters squared, you have to do this conversion twice. Because the first one will cancel out the square and the second one will cancel out, your normal one. And then meters times meters is meters squared. Now, I don't recommend doing it this way. To me, I find it easier to take 4.0 inches and convert that. First convert it, and then take your 6.0 inches and convert it. And then you can use this equation to calculate it. So area will equal, whatever that value is in meters times meters, and then you'll have here your meters squared. See, doing it this way, converting to meters first and then getting a meter squared, keeps you from potentially messing up here. But if you're going to do it this way, you need to be savvy enough that you know that if you have a square unit, you have to convert it twice. But either way, and I'm not showing you how to do this problem, remember, you have 2 significant figures here for inches, but up here, you have 4 significant figures. Don't let that be the reason why you miss points. You can only have 2 significant figures at the end of this problem. So whenever you calculate it, you can have more significant figures here, and you can even have more significant figures here, but when you report your final answer, it needs to have 2 significant figures. Let's look at one more. Let's see. How many moles of sodium? How many moles? So you are to know the conversion between moles and atoms. It says that you're only supposed to use the conversion factors here, but clearly you are expected to know your conversions between moles and atoms. Okay, so, excuse me, there we go. So here, remember that one mole, sometimes you hear people say a mole is a number. Well, 2.16 is a number. A mole is a quantity, and it's a quantity just like a dozen, just like a carton, just like a pack. If your parents smoke cigarettes, there's going to be 20 cigarettes in a pack. If you play cards, there's going to be 52 cards in a deck. If you go to the store, there's going to be 12 eggs in a dozen, or a dozen eggs. There's 12 eggs. If you get a case of water, there's going to be 24 bottles of water. Whatever. A mole is the same thing, but if you notice, the smaller things get, the bigger the number gets. So there might be 24 bottles of water in a case. There's 52 cards in a deck, and there's 6.0223 times 10 to the 23rd particles. Excuse me. 6.0223 times 10 to the 23rd particles in a mole. So if it says how many moles of sodium atoms correspond to 1.56 times 10 to the 21st atoms, so we have we're going to go from atoms to moles, and we know that we need atoms to cancel out, excuse me, and we need moles to be left behind. So here's our conversion factor. I can already tell that this is going to be way too close. Let's get this out of the way. All right. I'm going to walk the line. My atoms cancel out. My moles are left behind. Now, I have three significant figures here. This is not a significant figure. This is your scientific notation. Now, I have more significant figures here than I need, so we're going to end up with three significant figures. So I'll put in, and when I say particles, like you can have a mole of pebbles. You can have a mole of humans. You can have a mole of dogwood flowers. You can have a mole of molecules. You can have a mole of atoms, ions. Like you can have a mole of anything you want. That's why I use the word particles. So typically, though, it's going to be either a molecule or an atom. That's typically how this is used. Mainly because we don't have a mole of humans on the earth. That would be a lot of humans. So, now we put in the number of atoms. So we got 1.5. Oh, for crying out loud. 6 times 10 to the 21st. And we know that 1 mole is 6.0223 times 10 to the 23rd. Now, the way that okay, so you can put this in your calculator, or what I want you to realize is this. When you are dividing by exponents, you subtract this exponent from that one. So in the back of your head, if you have 10 to the 21st atoms and 10 to the 23rd atoms, I know that if 21 minus 23 is negative 2, my answer should be somewhere around negative 2. All right, so don't just blindly punch numbers and not know what to expect on the back end. If this was 23rd and this was 23rd, those will cancel out. 21st minus 23rd is negative 2. That being said, on your calculator, I'm going to punch 1.56 and you're going to hit the EE button. So you might have to hit second or function or something, but you want to hit EE and then 21. And then I'm going to divide that by 0.60223 and we'll hit EE again, and it's going to be negative 23rd. That is not correct. Do you see what I just did there? I put negative 23rd, and I ended up with a stupid number. I ended up with like 3 times 10 to the 43rd. Clearly that's wrong. Even your professor, even right now, well, granted, I just had a head wound, but aside from the head wound, even I make mistakes. I make a prediction of what the number should be about, and then I make sure that my calculator does it correctly and that my meat sausage fingers don't hit the buttons incorrect. 1.56 EE to the 21st divided by 6.0223 EE to the 23rd, and I ended up with 0.002. All right, so that's 2 times 10 to the minus third. I'm pretty close. 0.02903. All right, so I ended up with 0.00. Okay, I just found the erase button. 0.025 Okay. Remember, these zeros are placeholders. This one is real. So this is 4 significant figures, but I only need 3. So I'm going to round from my 4th significant figure to the 3rd, and I'm going to go ahead and put this in scientific notation as well. So, well, we'll do it in 2 steps. 0.00259 moles. Now, so this is sodium atoms, right? So this is atoms of sodium. So we're going to report that you have 0.00259 moles of sodium. This is going to be part of your answer. This is part of the problem. So you have atoms of sodium, you end up with moles of sodium. I'm going to warn you, do not just put atoms to moles, because atoms to moles of what? That doesn't tell me the answer. You started off with atoms of moles, or atoms of sodium, you end up with moles of sodium. So trust me, it'll behoove you, when you are doing this, do not lose what it is that you're converting. Okay? So this one's about the same. So this is one of those questions where you have to know that this, if I say that you have aluminum, if I have a car, one car has 4 tires. So if I have 1 mole of cars, I have 4 moles of tires. Which means if I have 1 mole of aluminum oxide, I have 2 moles of aluminum. So now you need to convert that. So the way that I would do this, let me delete some of this. The way that I would do this and accentuate my knowledge and let the professor know that I know what I'm doing. I would say this, okay, 1 mole, I'm going to set up a conversion factor of aluminum oxide is 2 moles of aluminum. So there is your conversion factor. So if I said, okay, how many moles of aluminum are in moles of aluminum oxide? So I'll go moles of aluminum oxide. And then I need a conversion factor that gets me to moles of aluminum. Well, I know moles of aluminum oxide needs to cancel. And I know moles of aluminum need to be left behind. So I've got 1 mole of aluminum oxide gives me 2 moles of aluminum. Now I can plug in my values. So I can go, well, first I can walk the line and make sure that my units cancel out, and then I'm left with what I want. So I'm asking for how many moles of aluminum. I've got moles of aluminum here. I got moles of aluminum there. I know I'm set up well. Now I start punching in my number. I see that I need 3 significant figures here. So I'm going to need 3 significant figures there. So 2.16 times 2 is like 4.32. All right. Now that's everything I need. I have a conversion factor. I have the correct number of significant figures. I have my units moles of aluminum. I have the work shown that I have my conversion factor plugged in, and I have an equation going from what was asked to, or what was given to what is asked. Like, this is a solid problem. Like you're done. Like, you're good right here. Now, when you do to set up a stoichiometry problem, you're being asked for mass in grams, and you're being given moles. So we know that molar mass is always in units of grams per mole. So we need to figure out what is the molecular mass of iron. So I can look on the back of my lab notebook or my lab manual and see that the molecular mass of iron, the atomic mass or the molar mass of iron is 55.845. So we're going to go, okay, 1 mole iron equals 55.845 grams. Now I can set up my conversion factor. So I'll go, okay, moles, my dimensional analysis, moles, mass, but we know we want the mass in grams, so we're going to put grams, F, E. I'm going to give a little subscript FE over here. We have a conversion factor, so we can go ahead and create that. We know that moles of iron is left, or goes away, and grams of iron is left, and we're going to walk the line, make sure these cancel out well. We're going to plug in our values. 1 mole is 5, 8, 4, 5. Now I'm going to plug in what I was originally given, which is 1.35. Now there's 3 significant figures here. There's 5 here, so we need 3 over here. So 1.35 times 55.845 equals 75.39075. Okay, so don't do this on your paper, but I need a little extra room. So we got 75.39 grams of iron. I'm going to take and round that over. So now I have 75.4 grams of iron. All right, so you'll be using a pencil, like you're not going to be using a marker on the screen like I am. It's going to be a little bit cleaner. But even as messy as this is, I can see your conversion factor. I can see where you set up your dimensional analysis. You know, you're keeping your units all the way across for grams of iron. You know, don't just put 1 mole in gram. Like, you need to keep if we're talking about moles of iron, then or grams of iron, then you need to make sure you put your element, the iron and the iron. Because a mole of copper and a mole of iron is different. I mean, the number is the same, but like the gram is going to be different. So keep your elements when you're doing stoichiometry. It's just part of the problem. So here you would do moles of copper phosphate. You know, so instead of putting this, you might say, okay, you know, we're going to call that CP, copper phosphate. And you might kind of shorthand it if you don't feel like writing the whole thing out. That's fine. Just make it clear. And then this one, you just kind of reverse engineer it. And then this one's going to be your multiple steps. So you're going to have to go, how many total number of atoms are in 2.6 moles? So you're going to have to go from, for instance, 2.6, all right, sorry, 0.6 0.260 moles of glucose, you're going to have to transfer that or translate that into moles of carbon. Moles of carbon, and then you have to go from moles of carbon to atoms of carbon. Now we did this, up here at the top. Right there on number 7, you did that. You did this one, I believe, at the top of the page. Yeah, no. Hold on. Moles of carbon, atoms of carbon. Yeah, well, you basically did it in number 6. You just did it in the reverse order. So you have all the skills necessary to do it, and you can either do it, you can do it all in one in 2 steps, so that your moles of glucose you can go ahead and translate that into moles of carbon, moles of hydrogen, moles of oxygen, and then you can go from moles to atoms, of carbon, hydrogen, and oxygen. Or you can do it in one step. You can go straight from moles of glucose into moles of carbon, straight into atoms of carbon. So you can do it in 2 steps, or you can do it in 2 different parts, where you go from moles to moles and moles to atoms, or you can do it from moles to atoms of carbon, moles to atoms of hydrogen, moles to moles of atoms of oxygen. So there's 2 different ways you can do it. So I'm going to pause here. If you have any questions, let me know. Set up a time. We can jump on a Zoom call. You can come to my office hours. But I hope this helps. Let me know if it does. And Godspeed and God bless, and we'll see you soon. Tuesday night, this is still going to be, this will be due. Either bring it to class to your Tuesday night lab with your lab report for the copper lab, or you can, if you need a couple of days, you can turn it into my box on Thursday in room 406 in the chemistry department. Those are your 2 options. So be well.